Hey Gr9s, welcome back. This is lesson 1 video 2. So in the last lesson I showed you using the online FET circuit simulator how to construct the two circuits, a series circuit like the one on the left and a parallel circuit like the one on the right. Okay, I've color coded this to show you that anywhere along the red line, so anywhere along this red line, the current will actually be the same. And in the ammeter readings from the previous video you would have seen that the current everywhere was 0.75 amperes. For ammeter 1, ammeter 2 and ammeter 3. Okay, I've done the same for the parallel circuit on the right, so anywhere along the blue line the current will be the same. And have a look, ammeter 1 over here has got a current of 3 amps flowing through it, and ammeter 5 over here has got a current of also 3 amps flowing through it because they're on the same line of the circuit. Okay, then for the green line, that's this one over here, anywhere along there current would be the same. So even if I put another ammeter over here, it would read, if that was an ammeter, it would read exactly the same as ammeter 2. So both of those would have a reading of 1.5 amperes. And then lastly, we've got the orange line of the circuit. Anywhere along that orange line, current will be the same. And you'll notice we've actually got two ammeters, one before the bulb, one after the bulb. And in both cases, the current on both of them is 1.5 amperes. Okay. Notice how current would go from the negative terminal of the cell, or if you're talking about a conventional current, from the positive terminal. So that would be the direction of a conventional current. You indicate that with a capital I. That's the direction that a positive charge would move if that's a positive terminal of the cell, and a positive charge was near the positive terminal, it would be repelled, so current would go anti-clockwise around the circuit. If we ask you to show arrows, you do it like that. Okay. But which way would an actual current flow? So an actual electron would be repelled by the negative terminal of the cell. There's the negative terminal and an electron would be repelled, so an actual current would go around this way. So I'm going to trace this path and I want you to notice how it splits. So current goes to this point. Some would go down the green line and some would go down the orange line. So that's why all of the current goes through ammeter 5, all of the current goes through ammeter 1. And that's why ammeter 5 and ammeter 1 have both got readings of 3 amps. Whereas along the green line, ammeter 2 and ammeter 3, it splits, so the current is less. And you'll notice how 1.5 and 1.5 add up to give you the 3 amperes. Okay. So the conclusions were done in the last video. Current's the same at any point in a series circuit, and current split or divided between the branches of a parallel circuit. Now we're going to have a look at the relationship between current strength. Remember, the symbol for current strength is a capital I. Charge is Q, and T is time. So the formula that you're going to write down, Q is equal to IT. Q is equal to I, current, times time. So charge is equal to current times time. Q is charge. The unit for charge, if you remember from your SI units, is the Coulomb, and the symbol for Coulomb is a capital C. I is current. Symbol for current, capital I. T is time. Symbol for time. Sorry guys. Symbol for current is capital I. Symbol for charge is Q. Symbol for time is T. So Q, I, and T. But here we're going to have what their units are. So time is measured in seconds. Current is measured in ampere. And charge is measured in coulombs. Okay, so charge, symbol for charge is a Q, charge is measured in coulombs, and the symbol for a coulomb is a capital C. Okay, sorry about the mix-up there. If you're used to using magic triangles, you can rearrange that formula. So Q would be on the top, and Q is equal to I times T. So what that means is that current I is equal to Q over T, and T for time is Q over I. Okay. All these formulas come from that base formula. You will be given that base formula in tests and exams, but you need to know how to rearrange it into one of those two if you need to. All right. Let's look at the definition of a Coulomb. 1 Coulomb Call that 1, the number 1, and then capital C for Coulomb. All a Coulomb is an amount of electrons, a packet, if you will, a packet of electrons. So just like a dozen bread rolls means 12 bread rolls, or 1 week means 7 days, or what's another example? A month is 30 days, give or take a few days, but a month is a packet of days, a dozen is a packet of bread rolls, and a week is a packet of days. 1 Coulomb of charge is a packet of electrons. How many electrons? That amount, 6,25 times 10 to the power of 18 electrons. We will give you that value in tests and exams. Okay. So on your calculator, you're going to, in your calculations, you're going to go 6,25, then you're going to use the times 10 to the button at the bottom, and then you're just going to type 18. All right, and what that is a quantity of electrical charge that passes through a given point in a conductor in an amount of time. How long? 1 second. 1 second. Okay. And when that will happen when the current strength is 1 ampere. Symbol for ampere is an A. All right, so if we've got the formula Q is equal to IT, if I've got a current of 1 ampere and a time of 1 second, 1 times 1 is going to give us 1 Coulomb of charge. So Q would equal to 1 Coulomb. Let's have a look at an example. If a charge of 0,020 kilocoulombs, remember kilo means times 10 to the power of 3, flows for a period of 5 seconds, so that's our time, that's our charge. What's the strength of the current? So they're wanting us to calculate I. So we've got Q is equal to 0,020 kilocoulombs. And on your calculator, if you type 0,020 times 10 to the 3, it will tell you that that's actually 20 coulombs. Okay. Time, we don't have to do any conversions there. That is just 5 seconds. And they're asking us what's the current. Okay, what's the current? So use our formula Q is equal to I times T. I is what we're trying to calculate. Time is 5 seconds. The charge is 20 coulombs. Let's rearrange. So 20 divided by 5. If you divide both sides of your equation by 5, then you're going to have 20 over 5, because those 5's cancel, is equal to I. So I is equal to 20 divided by 5. And on your calculator, 20 divided by 5, if you can't do that in your head, is equal to 4 amps. 4 amperes of current. All right. Next one, what's the charge which passes a certain point if a current of 3 million microampere, remember micro means times 10 to the power of minus 6, micro, I'm going to do this one in a different color so that you don't get confused between the two. Micro means times 10 to the minus 6. Please don't forget your SI units. What happens when that passes, or that flows for 1 minute? Guys, minute is not the SI unit for time. You must convert to seconds. That is 60 seconds. All right, so the information that we've got, they want to know how many coulombs of charge. We've got a current of 3 million microamperes. And I told you micro means times 10 to the power of 6. And when you type 3 million times 10 to the power of minus 6 on your calculator, you should get that it's just 3 amperes. So type 3 and then 000, 000, then the times 10 to the button, the x to the button on the bottom of your calculator, and then negative 6. Please don't use the minus sign. Remember to use the negative up at the top left-hand side of your calculator. Minus 6, negative 6, gives us a current of 3 amps. Our time is 1 minute, which is equal to 1 times 60 seconds, which is 60 seconds. If, for example, you had a question that gave you 9 minutes, it would be 9 times 60. All right, let's substitute that into Q equals IT. So current is 3 amperes. Time is 60 seconds. And 60 times 3 will give us a charge of 180 coulombs. All right. I'd like you to try the next one on your own, and once you've done it, then you can pause the video, or pause the video and then do it on your own. You will need to first calculate the number of electrons, or first calculate the charge and multiply it by the number of electrons. So you're going to use your 6,25 times 10 to the 18. Right, pause your video and then do it. You would have had a current of 15,000 milliamperes. Remember, milli means times 10 to the minus 3. So on your calculator, you'd go 15,000. Press the times 10 to the X button on the bottom, negative 3, not minus 3, negative 3. And your calculator should tell you then that that is 15 amperes of current. Period of 0.5 seconds. We don't need to do any converting there, so our time is equal to 0.5, half a second. Q is what we're trying to calculate. They want to know the charge, and they also want to know the number of electrons. Okay, so first we're going to go Q is equal to IT. The hint says first calculate the charge. So the charge is equal to current times time. Current is 15, time is 0.5. 15 times 0.5 is going to be 7.5 coulombs. Okay, so we've got 7.5 coulombs of charge. Now remember I told you that a coulomb was a packet of charge. How many electrons are in each packet? 6.25 times 10 to the 18 electrons are in each packet, or in each coulomb of charge. So the number of electrons is the number of coulombs that you've got. We've got 7.5 coulombs times the number of electrons in each coulomb. And there are 6.25 times 10 to the power of 18 electrons in each coulomb. And that's going to give us 4.69 times 10 to the power of minus 17. Sorry guys, I've done it as minus 18. It's not minus 18, it's positive 18. It's a whole number. Positive number. So 6.69 times 10 to the power of 19. 4.69 rather, not 6.69. 4.69 times 10 to the power of 19. And our units are electrons, because that's how many electrons are in each coulomb of charge. So just to recap, calculate the charge. We've got 7.5 coulombs of charge. In each coulomb of charge, there are 6.25 times 10 to the 18 electrons. So if I said to you, we have 7.5 weeks, how many days do you have? You'd go 7.5 times 7 days. But we're not dealing with weeks, we're dealing with coulombs, and each coulomb of charge has got that many, 6.25 times 10 to the 18 electrons. So press the buttons on the calculator and you get 4.69 times 10 to the 19 electrons. That, guys, is the end of lesson 2. So tomorrow I won't be uploading any more lessons. You'll have your assignment to upload. Please make sure you only upload one PDF. Make sure that you change the title of the PDF to reflect your name and your surname and your class, so 9G, 9R, whatever class you're in. And then you upload that to the assessments page of the sciences team, and then you're going to record just a video of yourself with your poster and upload that also to your assessments. Please don't forget to do that. Also do it early tomorrow morning so that if you've got any problems you can message us about it. Then on Wednesday nothing's going to be submitted, nothing's going to be no more lessons. On Thursday I will do lesson 3. Lesson 3 is going to be on potential difference. Okay. Please message us if you've got any problems. Thanks, grade 9s. Bye.